Now, if you're watching the previous videos on this channel, you can remember we talked about the most failed question on the May 2019 CXC paper. This is part C of that question. So here, we are given the equation of a straight line as a third of x plus a seventh of y is equal to 1. This line crosses the y-axis at Q, and we want to find the coordinates of Q and the gradient of this line. So let's see how we can put our problem solving to use. Now first, let's try and find the coordinates of Q. Let's ask ourselves, what do we already know? Well, here we already know the equation of the line, and we know that points on the line satisfy the equation. And we also know that the line crosses the y-axis at Q. What happens at the y-axis? Let's do a quick sketch here. So if we think about it, what it's saying is that we have our axes and Q is on the line and also crosses the y-axis. At the y-axis, x is equal to 0 because we didn't go to the left or we didn't go to the right for the point. So if we use that fact, we already know the value of x. We can put it in the equation to find the value of y and then figure out the coordinates of Q. So that sounds like our plan. So let's try it out. So at the y-axis, x is equal to 0, okay? Because it's right on the y-axis here. This is our y-axis. That would be our x. When x is equal to 0, that means in our equation, it's going to become a third of 0 plus a seventh of y is equal to 1. And now we can solve for y. A third of 0 is 0, so that means a seventh of y is 1. And if y divided by 7 is equal to 1, that means y must be equal to 7. Therefore, Q, since we have the x value, which is 0, and the y value, which is 7, that means Q is 0, 7. Next, we want to find the gradient of the line. So that's what we want to know. What do we already know? Well, we already know that if we want the gradient, we can use either the equation of the line or we could use 2 points that are on the line. So let's find it using the equation of the line. If we're going to use the equation, it has to be in the general form. It has to be in the form y equals mx plus c. But it's not written like that now. So if I'm going to get the gradient, I need to rewrite the equation in this form, and then the coefficient of x is what is going to be the gradient. So let me do that. So I'm going to put a little line here, separate what I've already done. And now a third of x and a seventh of y is going to be equal to 1. So that means, let me come down a little. That means to get a seventh of y by itself, I could subtract a third of x from both sides. So I could do this and I could do this. So these are going to cancel. And that's going to leave me with a seventh of y is equal to negative third of x plus 1. Okay? Because that's what we have right here. Now, I need to get y by itself. I'm basically solving for y. So how can I do that here? Well, if y is being divided by 7, I could multiply the entire equation by 7 to get rid of that in the denominator. So I could say 7 times the entire equation. So multiplying the equation by 7, then that means I'd multiply a seventh of y by 7, which would just give me y. I'd also multiply negative third of x by 7, and that is going to give me negative 7/3 of x. And I'm also going to multiply 1 by 7. That's what that means. And 1 times 7 is going to be 7. Now, y is the subject of the equation. It's in the general form, and the gradient of the line is going to be negative 7/3. like you can see right here.